Hello and welcome everybody to another webinar here from Fronius International. Today we are going to talk about commercial PV systems with Fronius, and on this topic I want to bring in some tips and tricks that might help you saving some costs for these big commercial installations. Now this is just a sample out of many tips and tricks actually. If you're interested in more, we have online trainings online, which you can enter and check out themselves. And also, of course, on-site trainings here in Wels and also in our subsidiaries, where we go into a little bit more detail on commercial systems, on tips and tricks, and the whole installation process, of course. Now, before we go any further, I quickly want to introduce the team for today. It consists of my colleague, Tony. He's behind the camera today and answering your questions. So if you have any questions, please use the chat feature of GoToWebinar, send them in. Tony will text you back immediately. And also it consists of myself, I'm Chris, and I'm guiding you through today's webinar. Also, please note this is being recorded, so if you do not have time the full webinar length, although it is very short, or if you simply want to rewatch it once more, you will have the chance because it will be sent out on your email address, the recording, and also in the next few weeks you will find this recording on YouTube where you can rewatch it as well. Now, let's start with something that we do always. We take a quick look on the agenda. And the first thing I want to present to you is the current Fronius portfolio for commercial systems. So which inverters are there? What features do they offer? And then I selected for you today 3 tips that I want to go through in detail. Again, there are more than that, but I picked just 3 because I don't want to exceed a certain time limit, of course, and keep it interesting for you guys to watch it. Now, these 3 points are the site selection. So decentral and central inverter positioning plays a major role there. The second one is grid and system protection. There is a potential to save costs here with some integrated features I want to show to you. And the third one is about the feed-in management, where you have the option to regulate up to a certain system size with integrated solutions within Fronius solutions. All right, so this is the agenda for today, and I want to start with the first one, like I promised, with a current look, with a look on the current portfolio for commercial inverters. Now, the first one is actually a very well-known inverter from Fronius. It's about the snap inverter. We have this product on the market a few years already, but it is still very reliable and still on the market. And this specific one is called Fronius Simo Advanced. It has power range from 10 to 20 kilowatt, 200 to 800 volts on the MPP tracker range. So yeah, more or less shorter and longer strings can be connected here. And we have 2 MPP trackers for individual system design. Now this can be, of course, be integrated very well on commercial systems as well as on some residential systems. So it's a mixture actually. One of the new inverters at Fronius is the Fronius Verto. We launched this product in May this year in some of European markets. Now it's launching in more and more countries, of course. And what it makes out is a power range from 25 to 33.33 kilowatt. So it's a little bit bigger. The MPP voltage range is, of course, also a little bit wider now, 150 to 870 volts. So even shorter and longer strings can be connected. And we have a total of 4 MPP trackers. So this, of course, makes it very, very easy to design systems with it, as we have no problem with different roof angles, different roof sizes. All can be connected here on a Fronius Verto. Now, with these power classes, you can imagine it also plays in a bigger residential market, but also the small commercial. Now, if we come to bigger systems, we now have the Fronius Taro. This is already a product that has been launched for a few years now. The Fronius Taro is a 50 kilowatt inverter with MPP voltage range of 400 to 850 volts and a total of 3 MPP trackers. Now, if this is too small for your commercial systems, we also have, of course, a Fronius Taro Echo. Who is familiar with Fronius already knows that the term Echo in the naming already indicates that it is a bigger inverter for economically designed systems, PV systems. And the Fronius Taro Echo has 50, 99, and 100 kilowatt. 580 to 930 volts, so it is a little bit limited, and also it offers a 1 MPP tracker. But it is enough if I simply want to have a big south-orientated roof, for example. Now this is what it's designed for. And of course, what I always can do is to do a mixture of multiple of these inverters, if not all of them. So if I have a bigger roof, south-orientated, I do them all with the Taro Echo. Then if I have a small side roof, I can do it with the Fronius Inverter, for example. So this is of course also possible and meant to do that way. Now this is the current portfolio. I simply wanted to give you a quick insight on what you can currently purchase for commercial systems. Now I want to go into more detail on these 3 tips and tricks I have selected for you today. And as I mentioned, the inverter position, the site which you choose, plays also a major role for the system design. Now, all in all, for mostly every inverter Fronius, you have the opportunity to choose between indoor and outdoor installation. Both is possible, no problem. The installation site, however, should be a solid, non-flammable surface. Very crucial also to be to fulfill the normative requirements. The temperature range is very forgiving. -40 to +60 degrees Celsius offers you a broad range of temperature where you can install, hence also the outdoor installation possibility. Now, the big question you have to ask yourself is, what do you want as a system design? Do you go for a central or a decentral system design? Decentral could, for example, mean the top picture where you have the inverter out in the field near the module site, and therefore you have to go longer AC lines. Or central could mean, okay, you are located at one site, maybe in a container or in the building where also the transformer is located, and you have a shorter AC line, but a longer DC line. So this is very crucial to consider. And to give you also a quick comparison between these 2 types, the central system design offers you, of course, a very big benefit when it comes to inverter position, because all the inverters are centrally collected. They are all together at one site, which makes it easier for the installation. So it's all only one site. You do not have to go out in the field with a truck or so. You have only to position the inverters on one central point. And also it makes it easier for service, for the installation and the service, of course. If you have to go on site, you do not have to walk around the whole field. You go to the one site, all the inverters are located, and there you do the installation or the service, for example. Another benefit is that the module strings are collected via string boxes, and then the DC line is done via a bigger DC cable diameter to the inverter. And because the DC is of course a higher voltage, there you have lower losses, energy losses. So it also makes sense money-wise. So when we take a look on the right-hand side, on the decentral system, you have quite the opposite, of course. The inverters are distributed decentral in the system. But it also is an advantage there because all of the module strings that you do can be connected directly to the inverter. We do not need a separate box to collect all the strings. we do not need bigger copper DC cables for the longer strings. We simply connect them to the inverters, maybe with MC4 plugs, for example. So you see, both have advantages and disadvantages, and you need to decide which makes more sense. Of course, if you're more interested, I again want to highlight there are online trainings where we talk about 1.5 hours about this topic, where we give a lot more detailed insights, of course. But this is the basic I want to give you today: central, decentral, all the opportunities and also disadvantages of these two systems. So once more, design flexibility on the DC side is the key factor here. And one inverter that offers all of this is actually our Fronius Taro. The biggest inverter currently in our product portfolio offers both systems or an inverter option for both systems. The central system design, there we have a Taro pre-combined, where we have big DC clamps on the inside to connect these bigger DC cables, of course. So up to 95 square millimeter cross section can be used there for the DC line. And as I mentioned before, because of this larger cable cross section over long distances, benefit number one, we can go further with the DC line with bigger cross sections, and benefit number two, we have lower losses. And on the right hand side, for the decentral system, we have the Taro in the direct version. And the direct version offers you direct connection of the strings on the bottom of the inverter, and it's looking like this. We have here MC4 plugs from Stäubli, so the original are selected for this, and you simply connect your strings on the inverter. So again, no string combiner boxes are needed. We have all the necessary fuses integrated in the product, and also a very big benefit is that a monitoring on string level is possible with this device. So for example, if you have 22 strings connected to one Taro, that is the maximum, then you have the possibility to visualize 22 strings individually on SolarWeb and, for example, find out which one is faulty and which one needs to be exchanged or serviced. So again, benefits and disadvantage on the same side here, and you need to decide what makes more sense for you, for your system. Okay, both is possible, central and decentral, with Fronius inverters. And one more thing that it is possible with our inverters is to have a solution for grid and system protection. Now, the grid and system protection is mandatory and necessary for the defined plant sizes. For example, here in Austria, also in Germany, you have to have a grid and system protection for systems above 30 kilowatt. And it's basically to secure the grid from this plant that you want to connect to it. So if there is anything faulty, if the grid is down, you need to make sure that the plant will stay down and not feed into the grid, and therefore the grid supplier requires you to install a certain switch to it. That's the main idea behind it, like we can see in this picture on the right hand side as well. Now, what I want to offer here as a tip and trick is that for all the newer inverter classes of Fronius, so this is the Verto, the Gen 24 as well, and the Taro, they all have this component integrated that you can see on the left picture. It is called the pilot card. It's the communication and the brain, more or less, from the inverter. And on this card, we have a very small orange plug called WSD, standing for wired shutdown. And this is a direct link to our AC relays of the inverter. Now, if we connect something here and would pull the cable, or a switch would disconnect, then we would open the AC relays and the inverter would shut down immediately. As you can imagine, this could be used as a grid and system protection. Very effective, and you save a lot of costs because the expensive coupler unit can be spared. You can use the already integrated AC relays of the inverter. That's the idea behind it. Now, the very bottom bullet point is still very important. Attention, please. It is necessary to do a clarification with the grid operator. Not all allow to use this inverter integrated feature. Some of them may require you to still use an external unit. So please get in contact with them, check it out if it is possible to use the wired shutdown of Fronius, or if you need an external unit. Now, if it is possible to use it, here is how it works and how it looks like. It is meant as a safety feature. So as I mentioned, you can connect, for example, the grid and system protection to it, or you could also say, I want to use it as a switch off opportunity for a emergency button. So if you are at the building entrance, for example, there is an emergency button, and with this, you would activate the WSD feature and all the inverters would shut down. Could be come in quite handy for a fire safety reason, for example. So it's not only for grid and system protection, but for safety features in general. Now, this is how it works. It comes already pre-bridged with this small cable loop. And if you want to use it for grid and system protection, for example, you undo this cable loop and go from your potential free contact of your grid and system protection, for example. From there, you go with a 2-pole cable to your first inverter, connected there on the in point of our WSD button, and then from the out you go to the next inverter, again to the in, and from out to in, and so on and so on. And this would allow you to disconnect all of the inverters at the same time with one push of a button or with one measure from the grid and system protection. Now, in total, we can do a maximum amount of 10 devices, and the maximum distance in between the devices must not exceed 100 meters, because otherwise the voltage drop would be too high and it would not switch anymore. Yeah, so this is how it would work. If you're interested, please check out the possibility with your grid operator and make use of it if possible. Save some costs for your systems. All right, step number 3, or tip number 3 actually for today, is the feed-in limitation. Now, of course, for certain systems, it is required from the grid operator that you must not feed in the full inverter power, but only a percentage of it, for example. Maybe the grid is not built out the way they want, the transformer can't handle it, or whatsoever. The reasons can vary, but sometimes it's necessary to do a feed-in limitation. And we now have also a solution for bigger systems with Fronius inverters where you can do a central feed-in limitation. So in other words, for a system with up to 20 Fronius inverter, it's now possible to do it without an external device. Because previously, if you're familiar with it, you would use a plant controller, an external device, in order to control our inverters, to do a central feed-in limitation. Now, with the software 1.31, this is the minimum that you have to have in order for this feature to work. Now, with this minimum requirement of software version, you can do it from Fronius side now. And the way it works is you have one master inverter. This one master inverter is the one where we also connect the Fronius smart meter located at the feed-in point to it. And then we can have up to 19 slave inverters. These inverters can be Taros, Chen, Vertos. Also the older snap inverters can be slave inverters here. And the requirement for this to work is that all of the inverters have to be connected to the same network. For example, like here, visualized with a LAN cable, or also, yeah, it simply has to work with the same network. That's the most important thing here. Now, if we have set this up, we have one master with the smart meter and up to 19 slaves, then we can do settings. And these settings look like this on the master inverter. So what you see here is a screenshot of the web UI of the master inverter, and you go to the safety and grid submenu, and down here you find a button called export limitation. And the first thing we want to do is we want to toggle power control. Second thing is we enter the total DC power. Now, by this we mean really the total DC power. So all added up, every inverter added up here gives you the total DC power. Next, you set the dynamic control, in brackets soft limit. It's very crucial that you select here the soft limit and not the hard limit. The hard limit is only relevant for Australia. You can forget about this feature in the rest of the world. We only need the soft limit, and right next to it, we enter then the maximum feed-in value in watt or percent. So this is the value given by the grid operator. We enter it here. And last but not least, there are two features with a fail-safe mechanism, actually, or fallback, it's also called. So what should happen if we lose the communication from master inverter to the smart meter? And if I toggle this to on, it would simply regulate all the inverters down to 0% so that nothing is fed into the grid and could cause any damage. And the last topic is the limit of multiple inverters. Now, this is the feature that is new with the newest software. And this allows you then to go to step number 2, check the connection. So in the connection, as soon as you toggle this limit multiple inverters, you have a list of every inverter that is found within the network. This is why it's important that every inverter is connected to the same network. Now, all these inverters that you want to choose for this setting, for this feature, have to be selected here. You simply toggle this button here called Use Inverter. And before that, of course, you need to check if they are connected, if they are disconnected, which could, of course, be a reason when the LAN cable is not plugged in correctly, or if the inverter is not configured. Yeah, so you need to check if all the inverters are connected and online, and then you toggle them to use them. And most of all, please do not forget to hit the save button at the end, of course. Which brings us to the next chapter. We can also manually add inverters. So if they are not found, or if I simply want to set a fixed IP address, for example, you can add inverters also in this list. So this is how it works. You go to the additional inverters, type in the name, type in the IP address, set the Modbus address, note the IP address as well, very important for later applications, and then you click on Add. So this has to be done on the master inverter, and on the slave inverter we have to do also a quick setting. And this is also now a screenshot from the web UI of these slave inverters. You can see we are in the submenu called Communication, and down here there is a submenu called Modbus. And within this submenu, we need to toggle the slave as Modbus TCP. So this allows the slave inverter to recognize these orders from the master inverter and do something with them. The second very important toggle switch is further down below, called inverter control via Modbus. So when we hit these two buttons, then the slave inverter will follow these rules set by the master inverter. That's all. That's what we need to do on every slave inverter. And then we have a setting consisting of 19 slaves and up to 19 slaves and one master inverter. All right. One important thing again about these feed-in limitations with up to 20 inverters, it doesn't matter which type of Fronius inverter you select here to be a slave inverter, snap inverter, Taro, Verto, whatsoever. What's important is that the master inverter has to be one of the newer inverters. So again, the newer inverters is all the inverters with a pilot card. So Gen 24, Verto, or Taro. It is not possible to have the snap inverter as a master unit. That's the crucial and important thing here. All right, so that's it for today's webinar. We are at the end. Here again, I want to inform you that the recording will be forwarded in the next few days. And if you're interested, check our homepage for online trainings, the next webinars, and also our YouTube channel for how-to videos. If you, for example, want to know the exact settings for the feed-in regulation that we've just talked about, there is also a how-to video online where I talk about it in, I think it's 3 minutes. So it's a very short video giving you the most important information so you can do the settings on site at the customers. All right, so that's it. Thank you very much for joining us today, and I hope to see you soon in the next webinar. Then, goodbye, guys. Have a nice day.